Can I have your attention in 3, 2, and 1. All right, eyes up, phones away, and screens at 45 so we're not too distracted as I give the instructions. All right, so what you guys will be doing in a moment is you are going to take these 10 reactions and I want you to group them into 4 different groups. Now, when you look at them, you probably might think, how am I supposed to group these together? I'm just looking at a lot of words that don't make any sense to me. So I'm going to give you guys some hints to help you guys figure out how you want to group them. It's very similar to Vocab Detective, where I am not giving you the magic words. You are trying to figure out what the magic words are based off of the groups you have made. Are we good so far?
Yes.
Yeah. Marissa's making a face. She's like, I don't want to do this again. All right, so some hints to help you guys understand how to decode chemical reactions. The first off is that with each reaction, I've given you the word equation and the symbolic equation. So this is the word one up here, and I'm just going to annotate it in case you guys want some help with some of the vocabulary and to understand what's going on. This down here is called the symbolic equation. Now, it's important to know the difference between those two because the achieve level requirement is getting the word equations, and the merit level and the excellence level is getting the symbolic equations. So it's good to get us used to that to begin with. The other thing that we need to note in chemical reactions that's really, really important is the arrow, because the arrow can give us a lot of information. So this arrow here tells us a lot. If something is before the arrow, these are known as reactants. So those are the things that we are mixing together for that chemical reaction. Anything after the arrow on the right are the products, what we are producing. So it's really important that we have that information so we know how to decode when we're looking at things. So when I say reactants and I ask, what are the reactants? You can go, oh, it's sodium and it's chlorine. If I ask, what are the products? You can tell me it's sodium chloride. So it's all about using our vocabulary well. The other thing that I want to point out to you guys in these equations are these letters that come after the chemicals. Anyone want to guess what they might refer to? We see an S, we see a G, we see an AQ sometimes. I don't think we have any, we have an L down here. Any ideas what that might be?
Categories.
There are categories. What about states of matter?
Liquid.
Yeah. So if I have an L, that tells me that's a liquid.
And then it's solid AQ.
AQ is a tricky one. S is your solid. G is gas. And then AQ is aqueous. Aqueous. What does aqueous mean?
I don't know.
I don't know. That's okay. Aqueous means that the solid has been dissolved into water. So if you guys remember, the solid we call the solute. Sorry, the solute dissolved into water. Usually water, sometimes it's something else. Now that tells us a lot of information because it tells us states of stuff, which is going to be useful for one of our types of reactions. So if you want to note on your notebooks, the symbols S equals solid, G equals gas, L equals liquid, AQ equals aqueous. More can just be in your brain. AQ. Aqueous. Or you can just write solid, liquid, gas. That's all it is. I will scan these. I'll put them online. I don't know if you guys realize I link all my lessons to a Google site, and then you click on the Google site. There's video recordings, there's scans of my notes. It's all there. So don't stress if you miss something, or if you don't get something and you want to watch the video again. All right, keep going. All right, so like I said earlier, in a moment you guys will be classifying these 10 reactions into 4 groups. And the way you're going to group them is based off of several things. The first thing I want you guys to think about is how many reactants it has and how many products it has, because that'll be one way to start categorizing it. So when I'm looking at this first reaction here, I see that there's 2 reactants, but only 1 product. So that'd be the first thing that I would do. The second thing that I would do to help me categorize is look at the states to see if there's a pattern in that group regarding their states. Are you okay with that so far? So it's just like vocab detective. I'm not giving you the answer, but I'm giving you guys some hints to get started. Look at your 10 reactions, figure out how you want to group them. I would suggest start by grouping them by number of reactants and products. See if you can find a pattern there, and then look at their states and see if you can find a pattern there too. Okay? Hop to it. I'm happy if you guys want to listen to music while you work. I'm also happy if you want to work together. I highly encourage you work together. I also encourage if you want to Google stuff to try to help you figure out the answer, you're more than welcome to do that.
Is there a clue?
My 2 clues are go through and figure out what number of reactants and products each reaction has and use that as a grouping method. The other suggestion is use the states as another way to group them. Because I'm not going to tell you the answer. Well, I will, just not right now. All right, go figure it out. All right, ready for the answers? Eyes up. All right, the first thing I would suggest you do is, like I said, go through and number how many reactants and products you have. So this first one has 2, that one has 1. The magnesium and the oxygen, that's 1, 2. And then 1 is the product. All right. Next one, I had silver nitrate, so that's the first one. And then the second one, we see that little plus sign tells me there's a second reactant.
2.
So there's 2. This one?
2.
This one.
2.
2 and 2 things. Looking down here.
1 and 2.
1 and 2. This one right here. 1 and 2. Yeah, that's why I wanted you guys to cut it up. This one over here, 2 and 2. Down here, 2 and 2. Down here, 2 and 1. And then this one, 2 and 2. All right, so we can already see some patterns here. We can see some patterns that there are stuff that has 2 things going to 1. We see patterns where we have 2 things and then we still have 2 things on the product side. And we also see that we have sometimes 1 reactant and then 1 reactant and we form 2 products. So this is to help us classify the different types of reactions. So the first type of reaction is the sodium chloride, sodium, the chlorine becoming sodium chloride. So 2 reactants, 1 product. Next one over, 2 reactants, 1 product, and then this one on the bottom here is our last in our group, that one I wanted? Yes, that's the one I want. Last one on the bottom, 2 reactants, 1 product. So those 3 reactions, if we group them together, are examples of our combination reaction. So green is our combination. So with our combination reaction, what happened? Do I need to start the timer and you guys are going to lose your preferred activity time? All right, so the stuff that I've circled in green shows 2 reactants forming 1 product. Those are my combination reactions. So with combination reactions, what I have are 2 or more things reacting together to form 1 product.
What's this burger?
Huh?
What is burger?
Is it
12.
12:25?
25 minutes. That's 3 plus 5.
Hmm?
No, sheesh. That's. Don't say about one.
What time we got? How much time we got? Got 25. If you want, we can.
We don't want to.
We want to sing the whole.
How long is that?
All right. Next thing we are looking for. Now, the ones that have 2 and 2, there's quite a few of them. So what I will do is we're going to hold off and do those ones last because those are the most complicated to kind of shift through. The ones that are easier are the ones that are going from 1 to 2. So you see here another one that's going 1 to 2. So these 2 reactions are your decomposition reactions. So with a decomposition reaction, what is happening is we have one reactant one reactant that's breaking down to 2 or more. One reactant breaking down to 2 or more products. All right, I'll leave that up so you guys can get that written down. You can either write it down on your piece of paper or you can write it down on your notebook. Not what I wanted. All right. Shh. All right. The first group is a group of 3. You should have the sodium chloride chlorine becoming sodium chloride. You should have the magnesium plus the oxygen becoming magnesium oxide. And the third one you should have in that first group is the calcium oxide and water becoming calcium hydroxide. So those are the first 3 you should have together. Those 3 together are an example of a combination reaction. So combination reactions have 2 or more reactants, which all these have 2 reactants, and it only forms one product. Thus, we're combining things together. All right, next thing we have are our decomposition reactions, which is the 2 in the center. So you should have 2 reactions there, and the reactions that you should have are the calcium carbonate, 1 reactant, forming 2 things, the calcium oxide and the carbon dioxide. So you should write down, so you have those 2 together and write decomposition reaction. We have 1 reactant breaking down to 2 or more products. We see that here, 1, 2. The next one is sodium carbonate, and that breaks down into 2 things, the sodium oxide and the carbon dioxide. All right. Now, here's the challenging thing about our last set of reactions. All of these reactions here have 2 reactants and 2 products. So we can't group them based off of the product and reactants alone. So what I wanted to point out to you guys when it comes to the classifying is looking at the type of type of chemical that's there. So if we look at this first one here, we see that there's a mixture of elements, right? And we learned last week, if it's a mixture of elements, that is a compound. This one, potassium chloride. Is that two different elements? So compound. This guy, compound. That one, compound. Right, looking at this one over here, compound or element? Got lots of compounds. Compound? Compound? Compound?
No.
Sodium, sulfur, and oxygen. That's a compound. All right, going to look at our bottom two. Magnesium, is that by itself?
Yes, element.
So that's an element.
Compound. Compound. Element. Compound.
Element.
What the?
Just zinc, element.
Compound. Element. Element. Compound. Element.
So we notice now our two groupings, right? So these two groups have elements, the other groups only have compounds. So we're gonna circle those again, help get our colors. I'm gonna get some more colors.
What's the meaning of that?
Well, that's what we're gonna learn. So these two here that I'm circling in pink, the magnesium plus the hydrochloric acid making the magnesium chloride and the hydrogen, and the zinc making the copper sulfate and, zinc and copper sulfate making zinc sulfate and copper. These two are known as our displacement reaction.
Is that it?
So those two are my displacement reactions. Displacement reactions just mean there's something getting replaced and swapped out. In a compound. So it's swapping out an ion that's in my compound. So for this example here, you see how we had magnesium and it swapped out the hydrogen to form magnesium chloride, and then hydrogen got kicked out. It displaces it. This one here, you had zinc. The zinc replaced the copper got kicked out. So that's the displacement reactions. And then the last one, which I will do in blue, are my precipitation reactions. So this one here, there should have been 3 in that group. 1, 2, and 3. And that blue marker is dying on me, so let me get my other blue one. There should be 2 blues somewhere. Here. So those are my last 3. What you should hopefully notice with those last 3, do you notice on the reactant side, what state is everybody in? What state is everybody on the reactant side in? AQ. So they're all aqueous. And then when I mix them together, what happens? One stays AQ, in this case, but what else do we get that's new? Solids. Do you see that? Yay or nay? All right. So these reactions that I have in blue are known as our precipitation reactions. So do you guys know, like you've heard the term precipitate, like it's raining. So when people say it rains, it precipitates. In this case, it's precipitating a solid. So it's forming a solid when we mix these two things together. So precipitation reactions, we have 2 solutions mixed together. And a solid product forms. So those are our 4 different types of reactions.
Wait, what is, so she's got 2 sheep?
And those are our 4 reactions.
What did she say?